and good morning. My name's Martyn Jakins-Pollard, as was said. I've been working in the last 10 years or so in marine science from various different capacities. So the last 5 or so years I was working within DEFRA as a science lead, so working closely with policymakers to translate the science for their policy objectives, whilst also working with the wider research community, organisations like Cefas and others, including CEH, to ensure that there's existing research programs to support the policy objectives that they have. More recently, in the last few months, I've joined Cefas, and now I'm particularly working on blue carbon within that. So in terms of blue carbon science and policy, so blue carbon is regularly recognised as a nature-based solution that can contribute to climate change mitigation. However, from a UK perspective, we don't have the best understanding across all habitats about the potential value of that. So how much of a source or a sink are these habitats, and what is the scale that can be realised from an emissions perspective in the UK? So from a blue carbon perspective, there's a lot that we can still learn around carbon emissions and sort of the storage value of these habitats, but it's not the sole policy driver. As when we look at different blue carbon habitats, they have a lot of wider ecosystem benefits that they can provide. So by pairing up blue carbon with other parts of science, we can also sort of increase the value and compound the benefits that these habitats have, such as things like if you're restoring and managing habitats in a correct way, you might get coastal defences, you might have biodiversity benefits, might be fish nursing grounds and so on. So demand for evidence on blue carbon science is growing from a policy perspective, but it's fragmented and it's not always policy ready. So in terms of what blue carbon is, so the IPCC defined blue carbon as the organic carbon stored in marine and coastal habitats that are amenable to management. So the way we break it down is kind of by actionable, emerging and non-actionable habitats. So this is kind of linked to a few different criteria as listed on the slide, from the scale of removals or emissions, long-term storage, is it over decades and longer? Do human activities impact and drive those emissions? Is there actually the possibility for management interventions that can help enhance that stock or reduce the emissions? What's the adaptation value? So think about future climate scenarios and the potential to reduce emissions and change what we may experience in the future under climate change. And can these habitats be included under existing greenhouse gas accounting guidelines? So we have the actionable ones, seagrass, salt marsh and mangroves, where all of these criteria are true, or the majority of them are true and can be realised. We've got other habitats where maybe some of it is true, but not all of it. So for example, with seabed carbon, currently that's quite an emerging area. The science space isn't fully mature yet. And at the same time, we don't have any kind of accounting guidelines for greenhouse gas inventories. And then we also have non-actionable habitats where maybe they're not as amenable to management in the same way as the other examples we're talking about. Or, for example, it's quite difficult to measure whether they are a sink or a source in the same way as we do with the other habitats. So in terms of policy drivers, there's a number of different policy drivers that can sort of relate to blue carbon. These are just some examples, but it's about thinking whether there are legal obligations from a UK perspective. What are the questions that policymakers are then going to have in relation to those obligations, and where can the science help fill those gaps? So, for example, from a net zero perspective, some of those questions might be what actually needs to be counted against UK emissions targets, what habitats are relevant, what habitats do take up carbon and store carbon, what human pressures are influencing the storage and emissions in those habitats. Then from an international reporting perspective, how can we make sure that data is suitable to actually feed into the relevant reporting cycles? Is it measured and reported in a robust way that can actually be used on global scales? Additionally, when we look wider than just the blue carbon side of things, we've got biodiversity targets and nature-based solutions. So where are these habitats providing multiple benefits to society? What is the scale of those and how can we quantify that? And then equally, if policymakers are looking to prioritise restoration and protection of habitats, which areas should be protected? How should they be protected? How should they be managed differently? Where can we restore? And again, what does this mean in terms of the benefits from both the blue carbon perspective and those wider benefits? So the UK Blue Carbon Evidence Partnership was stood up after COP26, and this was really to align UK-wide blue carbon evidence, both from a policy and evidence perspective. So really it's about looking at what are the drivers across UK administrations, where are there common drivers that all of those administrations have, what are the primary evidence gaps and evidence that is available to support those drivers, and then looking at prioritising and delivering new evidence to support in terms of those objectives as well. I just want to quickly flag that Cefas aren't a partner on the UKBCEP, so I'm kind of presenting information about the UKBCEP, but wider colleagues in Cefas do sit in the meetings as the Secretariat, and Cefas do support alongside other organisations in terms of providing advice and support. So in June 2023, the partnership released an evidence needs statement. So this was really to look at those policy objectives I mentioned across the different administrations, where there are common areas, and then translate them into evidence themes. So an example of this is working towards the potential inclusion of salt marsh and seagrass in the greenhouse gas inventory. Other areas are looking at human pressures. So again, thinking about if you've got, I don't know, fisheries, for example, or other infrastructure and marine industries that are interacting with blue carbon habitats, how does that potentially impact the benefits that those habitats can have, both from a carbon sequestration perspective? Additionally, you can't look at those habitats just in a siloed way and kind of think of them on an individual scale, because they're all interconnected. So as carbon is flowing from land to coast to sea and offshore environments, think about how is all of these different things connected, and how is the best way to try and manage that and sort of understand those flows from one area to another. And then finally, just thinking about climate change adaptation itself. So are decisions going to be future-proofed? If we're restoring an area because it's a great store of blue carbon, but in the future that area may be significantly impacted by climate change, are those benefits and the wider biodiversity benefits and so on going to be realised? Is that decision future-proofed, and is it relevant in 20 years, 50 years, 100 years? So in terms of evidence themes that came out of that, there's some real key sort of pieces of information that the partnership and wider collaborators have been trying to move towards. So one area is standardization of methods. So across habitats and within habitats, there's obviously different approaches that are sometimes used to collect data on carbon storage. I think one of the key things here is trying to align that so that it increases the impact of the existing data. So if everyone's collecting things in slightly different ways that don't necessarily feed into policy or those greenhouse gas inventories and things like that, then it makes it more difficult to use the existing information and reduces the power of what's available. Additionally, with habitat mapping, we can better understand the extent of the habitat. So if we can then start to think about both the extent of the habitat paired with what is the capacity of this habitat to actually sequester and store carbon, does it emit carbon, how does it emit carbon, how much, and so on, then it's easier to start to put figures on the actual scale of benefit that these habitats can provide. And then linking back through to the sort of human pressure side of things, we've got the impacts of human activities and climate change. How is this going to influence those benefits? How is this going to influence how management decisions need to be taken? And what are the socioeconomic benefits and costs? So again, how does that relate to those wider industries like fisheries, infrastructure, like offshore wind and things like that? So good science isn't always usable science in a policy context. So I think it's really important to just keep sort of talking about this sort of area, particularly as I've mentioned a couple of times already around that sort of standardization of methodologies, having consistent methods, repeatable measurements and so on. And then equally being very clear in terms of the uncertainty in the data that exists. What are the assumptions that are underpinning this? What is the confidence? If it's better to take a decision sooner with limited confidence than later because the risk is higher leaving it, what is the precautionary use of that science? So these first 2 points are really important, and even things like when people are publishing and reporting, ensuring there's suitable metadata in there to enable that to then be compared against other existing work and to be brought together to, again, increase the power of the existing evidence base. So there's a lot of engagement work that has been happening and will be happening in the future around these sorts of areas. And I think Ruth, when she speaks a little bit later, will probably talk about some of these things as well, about potential opportunities to engage, as ultimately the partnership and wider research collaborators are looking to bring together as many people as part of this research community as possible so that we can basically increase the impact of the existing science and the future science that's being planned. Next is sort of think about trade-offs. Again, I mentioned earlier about sort of thinking in a siloed way. If you think about something from one policy perspective, maybe one management decision, it can often not pick up the nuance of the actual risks and impacts of that decision. So or even the wider benefits. So for example, if you were going to put a management measure in place in a certain area, it could displace fishing activity, it could displace infrastructure activities. And in reality, it may be that it displaces it onto areas that are higher risk from a carbon perspective and result in a higher emissions risk, or kind of prevent the sequestration and storage value of that area. So thinking about those trade-offs and thinking from a cross-policy perspective is really valuable. And then finally, it's just making sure that those outputs are really fit for policy. Different audiences obviously take information in different ways. Policy often have quite specific requirements in terms of the information that they need, especially when it's going on to national inventories and things like that. So again, it loops back around to that first point around standardization and approaches and methodologies that are used, but making sure that the outputs are actually tailored in a way that enables policymakers to make decisions that are relevant to the evidence, and the evidence is relevant to the decisions and problems that they need to think about. So just some examples of where this has been making a difference in terms of the UK Blue Carbon Evidence Partnership so far. So in February 2024, a working group was stood up on salt marsh in relation to the greenhouse gas inventory. I think Annette's going to talk a little bit about this kind of work as well. The CEH have been heavily involved in developing a roadmap of evidence needs to better quantify if salt marshes are a net sink or source of carbon emissions, and also how to actually sort of move forwards that process and getting them added to the greenhouse gas inventory from a policy perspective. Additionally, Ruth will probably be talking a little bit more about seabed carbon. There's been both an evidence review that was conducted at the start of this year, and that was really bringing together the state of current evidence around, with a particular emphasis on fishing and trawling, thinking about where we are in terms of what we understand, trying to start to put some confidence and quantification attached to different parts of the process of fishing impacts on the seabed, and then thinking about how that potentially translates in the future to emissions. And additionally, Ruth's done a lot of work in terms of building a community around those methodologies and the approaches for data collection within blue carbon at the seabed. So again, there's some technical guidance that's being produced and should be out, I think, at some point in the near future, which maybe Ruth can talk to more. And that will be to try and provide a bit of a guidance to other people in terms of best practice, in terms of approaches that can be used by policymakers. Finally, just collaboration and future plans. So again, I've mentioned numerous times that it's really important to try and work together across this area, as ultimately all the different science that's happening, if we can bring it together and make sure that data can be compared with each other and used together, it just maximizes the input to that in policy. It means it's not just having a scientific impact of improving the evidence base, but it's bringing things together and having a real impact in terms of how decisions are made and then how that affects the UK as a whole. So just finally, some ways that you can kind of get involved or find out a little bit more about this. So the UK Blue Carbon Evidence Partnership has on their website a project directory. So you can submit your work to that, and then it can be tracked alongside other work the partnership's aware of to see what different things are contributing to the evidence base, and then help guide where there are gaps and prioritise where maybe there could be needs in the future that could be filled by different research organisations. Equally, just bringing your communities together with the partnership, reach out to the Secretariat, have a chat with them, get involved, find out what's happening and what people need and what people are looking for, as ultimately if everyone's doing slightly different bits of science but on the same theme, it would be very helpful for everyone to just try and bring things together a little bit so we're all doing something that kind of moves towards that common goal. And then finally, aligning your research with the evidence needs. If you're thinking about maybe setting up a new project, you're currently developing some work at the moment, have a look online. The evidence needs statement is published. You can have a look through the priority areas and see how your work fits. And then, as I said already, you can kind of bring that together with the partnership and have a discussion there and see if there's any value in working together. So that is it from my perspective. So obviously, feel free to reach out to myself or the Secretariat if you have any questions or anything. And I think I'm now handing back to Anna.
Well, thanks for that, Martyn. That was, really interesting. So we'll just move straight on. So if you have any questions, save them up and we'll get to them at the end. So I'm just going to introduce the next speaker, which is Ruth Parker from Cefas. And she's going to be talking to us about how we're kind of assessing seabed carbon storage and the kind of pressures on these systems and management options. So I'll let you take it away.
Thanks, Anna. Hello, everyone. I'm Ruth Parker. I'm a biogeochemist and I'm a lead blue carbon advisor at Cefas. And I've been asked to give you an overview of our R&D work on seabed carbon. As Martyn mentioned, it links very closely to the evidence needs statement. So a lot of the work that we're doing links back to questions there. I'd first of all like to give an acknowledgement to the whole team that are supporting all of this work that's happening across Cefas, and also the funding from DAPRA. But it's going to be a bit of a skim, so if there's elements that you're particularly interested in, please do get in touch and I can provide some more details. So why is managing seabed carbon as a submerging habitat so important? Well, I think we're all aware that there's quite a considerable amount of carbon that's locked away and stored in seabed sediments, which prevents it from getting and staying in the atmosphere. But the question is that obviously disturbance and degradation of this carbon from different activities can release that back into the atmosphere potentially. Some of the activities sort of imaged here in the infographic. But management or habitat protection on one side could prevent avoided emissions, so it keeps that carbon in the seabed, not up into the atmosphere. But on the other side of that, habitat restoration and potential recovery can allow the carbon stored or recover of those storage representing an emission saving. So there's two tensions there when we think about management. In terms of policy, what are the key questions that we're being asked? Really, in terms of seabed carbonates, well, how much is there? Where is it? So in other words, what's the climate change mitigation potential of these habitats? Are they at risk from activities such as trawling? And how does these impacts and distribution of pressure relate to management measures such as the MPA network? So I'm going to just provide an overview of the three elements that we work on to try and bring that together. That's understanding carbon provision, understanding impact, and then management. And just sort of to go back to carbon sort of 101 in the seabed, I'm sure most people know this already, but just to remember that what our key parameters are organic carbon stock and organic carbon accumulation or burial. That's the Climate Regulation Service. So stock is the amount of carbon residing in the seabed, but organic carbon burial accumulation is the rate at which carbon is added to the stock year on year. And as Martyn mentioned, I've been working with a colleague, Claire Mason, on this methodology to standardise the way that we parameterise those two key variables, and that should be released soon, hopefully. And then another key parameter is organic carbon composition. So that sort of rolls up reactivity and source, and both of those really control the sort of degradability or reactivity of the carbon in the seabed and potentially its response under impacts and management. So where have we got to in terms of understanding carbon provision? Well, we really understand the main factors in terms of understand the control, the storage and sequestration is the input. That could be from marine or terrestrial sources. The capacity of the sediments to store carbon, that's mainly the sediment type, but also oxygenation or whether a sediment is diffusive or advective. And then carbon degradation in terms of either depth or temperature that's controlling remineralization, the biology and biodiversity associated with that, and also carbon stability. So the sort of actual nature of the carbon itself. And this varies in space and creates the stocks, burial accumulation or overall sequestration levels. And in some areas, we're doing really well in terms of evidence. We've got sort of good carbon stock maps that have been around for a good few years now. The one I'm showing there is Marcus Deasing's map from 2017. So the blue areas are the high carbon areas and the grey are the lower carbon areas. So the high stocks seem to appear in muddy, deeper, colder areas. And English waters sort of contain about 80 to 100 million tonnes of organic carbon. We're not in such great shape in terms of understanding accumulation and burial, partly because those measurements are a lot more difficult. You need corers and some of the radiochemical techniques are more expensive. But we do know that they are related to the stock, but obviously not in a one-to-one relationship. So some areas are more efficient in preservation, and in particular, the role of terrestrial carbon can affect that. We're also learning that there are different types of stores when we just look at the map. So some stores can be active, so they have potential to recover and deliver this emission saving potential. But some carbon stores are very old, very relic. They might be several thousands of years old. And obviously how we manage those depends quite considerably on their state and activity. So thinking about then provision, what are we doing in terms of understanding carbon composition? We know that this is a key factor in controlling response to pressure. And what we're interested in is what part of the stock is actually reactive. can we manage it? Is it recoverable? So there's several activities we're undertaking. We're trying to develop a toolbox that we can test across the UK shelf to describe composition and source. And there's a whole range of analytical techniques, and we're working with the community at Leeds, St Andrews, BGS and others to sort of develop and test this toolbox. We're also thinking about how we can develop maps. And these are maps of thermal TGA, thermal gravimetric analysis, so it's a ramped oxidation technique, which starting to give us an idea of where the stock is and how labile it is. So across the UK, or the areas we've looked at, about 10 to 35% of the stock is labile. It's interesting to see then that most of it is refractory or recalcitrant. This is defined by this method as not labile in the biogeochemical sense. And we get increased total labile on the inshore, so this sort of area here. But also we see an increased proportion of labile carbon or reactive carbon offshore. And we think this is because of the temperature limitation in the northern part of the North Sea. So we're expanding this to the North Sea and the Celtic Sea, but we're really keen to develop this overall to English waters as a whole. And one of the key questions that we're having to tackle is, what is reactivity? We've got some great analytical definitions, but we need to compare that and ground truth that with microbial degradation. So when an actual sort of carbon is disturbed, really what happens to it? And that's really important in terms of understanding what the definition of labile is that's relevant to climate change mitigation. So the carbon that would naturally make it through processing in the upper part of the sediment to long-term storage. And we're still considering that and thinking about that as we go forward. And the main thing is then that we're trying to bring all that together to understand different provisioning regions. And I don't think I've got quite the time to describe them all, but it means that as we look across the North Sea, we've got different areas. Some are storing carbon really efficiently, some are processing it very efficiently, so they're very effective bioreactors. And we're trying to understand a mechanistic understanding of these different regions, what's the role of terrestrial input, but also what's the effect of temperature controls on degradation. And that helps us understand regions, and because of course this is the baseline understanding to impact and impact response and management. So I'm sure many of you are aware that this topic has been sort of had active discussion over the last sort of few years with high profile publications, and it's still on the agenda, and it's not going to go away anytime soon. There's still plenty of discussions at international meetings, there's ministerial focus, and there's also advocacy for protection in different parts of the shelf. But however, we've got quite a lot of uncertainty still within our evidence base and a lack of consensus. So what we're really trying to focus on as our under the evidence partnership, but also as our role as DEFRA's agency, was to try and bring that consensus together. So we undertook a community review that was published in February that Martyn mentioned, where we had over sort of 30 national and international authors, where we looked at the carbon risk from different activities such as trawling, infrastructure development and climate change. And we thought about the management options. And the idea was to really understand what we knew, where the confidence level was, where were the key gaps and the next steps. And the aim really was there to try and develop consensus around what we know, support the development of management measures, but also provide a platform for wider stakeholder discussions going forward. And we hope these documents will remain live as new results emerge from different programmes going forward. So I don't have time to go into all of the detail. The links were there in the previous slide, so hopefully you'll be able to follow those and look at them for yourselves. But what did we do in thinking about trawling? Well, we reviewed the key steps of the carbon risk pathway, going from what we understand about the carbon within the bed, how much is there, and is it reactive or labile? What happens when gears interact with the bed? Are they mixing, disturbing sediment or resuspending it? What happens as it's transported and deposited? Is it degraded, and what might be the fate of that DIC, and ultimately what controls emissions? So the two areas that we focused in The first was within bed change. So what is the long-term sort of changes in budgets? And really what we're finding is there's no clear understanding of net change of carbon storage. Within the English waters, there's only 12 to 15 studies. Some of them haven't even really included blue carbon aspects. And even the international reviews give no unclear, sort of clear message. But the evidence base is rapidly growing, and we're keeping a clear eye. There's some NERC highlight topics that are focusing on this area, and also some convex seascape work. So there's a lot of new data coming in, and we're keen to keep an eye on this. But an area that we did focus on to try and come up with some new estimates of the significance of this process was looking at the disturbance effects versus the resuspension effects. So where carbon stays within the bed versus whether it goes into the water column, and the associated risks. So we focused on improved gear action knowledge, so understanding the ratio between those two and how that relates to penetration depth, and also thinking about carbon reactivity. And we had a first pass map to inform that. And we were able to come up with some sort of what we're calling maximum carbon at risk estimates. So it's like the worst case scenario, the estimates of the total amount of carbon disturbed and resuspended, given the uncertainties that we had in the other areas. And so we were able to revise some of these estimates to these numbers here: 0.33 million tonnes label carbon resuspended, and the CO2 equivalents of that. So what's interesting is that the numbers have come down. They are still significant, but they're not as big as some of the claims published previously in terms of aviation levels. So it was really helpful to sort of revisit those numbers. So what does this mean for management and protected areas and carbon interactions? Well, there's been quite a lot of calls for a protection of the whole network as a blanket, and I think what the review was helping us understand is that's not necessarily the right way to approach it. There's always the devil in the detail. So for English waters, the carbon storage and disturbance most of it actually sits outside the MPA network, which is not surprising because that's not what the MPA network was designed for. It does mean that there's an interaction between the location of the carbon stocks, and the reactivity is complex, and it needs to be thought about when we're thinking about protection. There's different carbon types, and also some of these areas have different impact history. So the maps that I'm showing there is the left is the organic carbon disturbance across sort of English waters and the extent of the carbon maps, and then the right is the resuspension. You can see that some of those really high pressured areas sitting outside the network. So we've got to really think about the dynamics between the network and where the activities are really happening. Other work has really shown as well that we've got to be really careful, because closure can actually increase organic carbon pressure and potential release. So this was a scenario that we did for a highly protected marine area, where it had low carbon and it's surrounded by higher stocks that are quite reactive. And actually the closure of that MPA increased reactive carbon disturbance by 5 to 10%. So it's really careful that we're really careful that we need to take account of carbon reactivity and what's sitting around the network when we're thinking about management decisions. So it means that blanket closure and protection of the MPA network doesn't necessarily deliver the net zero carbon objectives and could lead to different outcomes. These are mainly, some of the key assumption is understanding the trawling relocation effort when areas are closed, what sort of displacement happens. For that, we need to understand decisions that our fishers are making, and that all comes down to socioeconomics. So it's not quite so straightforward as it might seem. So how do we move forward? So I think really where we're trying to go is that we need a nested approach from a regional identification of prospective sites that are good, and then a local scale scenario testing. So the two maps here identify as a first pass areas that are good for mission avoidance. So those are areas of higher carbon that are potentially unfished, but they potentially have sort of could be quick wins. But emission savings where areas are pressured already, but need to think about their recovery potential. And then we need to move down to local scenarios, which integrate, what is the carbon reactivity within certain areas? What's the net effect of the chronic impacts that have been going on? Has it changed carbon reactivity? But do we understand displacement decisions when areas are closed? And we're thinking more towards feature-based management and identifying key stocks for particular reasons. Ultimately, though, we talked about spatial management measures, but we need to think about sort of temporal management measures and also changes of mode of action as possible. So particular gear modifications that are already happening due to biodiversity, which might be useful. And also linking up policies. So we've got fisheries or food security policies, climate and biodiversity, and they really need to come together to ensure that we don't have management decisions with inadvertent outcomes. So just to finish off then, that was a very quick skim on seabed carbon. The other areas of development, when we think about seabed management, infrastructure and sector impacts, very important. Obviously, there's a large amount of human activities going on in the seabed, and we don't have good certainty on what they do to seabed carbon, and we need to think about that going forward a bit more. Climate itself, impact and adaptation, of course, will change the input of carbon to the bed, the within bed processing, there's changes in storminess, all potentially are significant and still have quite low confidence. The interaction between biodiversity changes and protection is key. We're not sure that biodiversity recovery will be a win-win for carbon, and we need to understand a lot more of the biological control on organic carbon storage. And then, as I mentioned before, the links to emission are really low confidence, and we need to really understand better the seabed impacts of and how it propagates through pelagic processing or buffering to sea air exchange. So looking forward, as Martyn alluded to, this topic area is very fast moving, and we're really keen to build community consensus as the evidence starts coming in. That's not just within the UK, but internationally. But I'm really keen to highlight and develop the community collaborations where possible. We've got some engagement opportunities coming up on biodiversity and carbon, trawling impacts, and also we're keen to develop these maps that we have towards a sort of one community-based live with higher confidence we can for stock reactivity and burial. And so please do keep an eye out for a data call that will be coming out. Please let me know if you are interested in looping into any of those topics. I'd be really pleased to hear from you. Thank you very much. I think now I pass back to Anna.
Brilliant. Thanks, Ruth. That was fascinating. There's a lot of science going on. There's a lot to untangle. It seems like it's quite complex to get it sorted with the policy as well and these management decisions. So do you put any questions in the chat as you think of them? And we'll move on to our final speaker, which is Annette Burden from UKCH. And she's going to be talking about work on salt marshes in the context of net zero and blue carbon and the kind of UK greenhouse gas inventories. And this work is very much supported by Hannah Clevard, who's also just joined the call, I think. So take it away, Annette.
Thank you very much. Yeah, so I'm Annette. I work for the UK Centre for Ecology and Hydrology. I'm a wetland biogeochemist. And alongside Hannah, who also works for UKCH, we kind of lead the blue carbon work here. So this is very much a joint presentation between us. Hannah has just joined, but we work on all this together. And we thought it'd be a good idea to just explain what a greenhouse gas inventory is to begin with, so everyone's on the same page. So it's a kind of year-on-year assessment to monitor progress towards global and national commitments on reducing greenhouse gas emissions. And there's the idea behind it is there is continuous improvement, there's annual expert review, the greenhouse gas inventory is calculated yearly, going back to a 1990 baseline. And it also tracks impact of policy and what policy needs may be, etc. So the UNFCCC have this specific goal to stabilise greenhouse gas concentrations at a level that would prevent dangerous human-induced interference with the climate system. Now, the national greenhouse gas inventory is split into different sectors, which are shown here, energy, industry, etc. And then the land use change and forestry section is what we're going to be talking about. And then the national greenhouse gas inventory itself is part of the national atmospheric emissions inventory, the scientific steering group meeting of which is what Hannah has been at today. And the kind of principles behind inventory compilation is you have emission factors. So emission factors represent a value that relates a pollutant quantity that's released or removed to a unit of activity. And then those emission factors are used in a tiered approach to account for and reporting of greenhouse gas emissions. So the IPCC guidance has default emission factors alongside other parameters, and that is a tier 1 approach. If you include something into the inventory, you can use that default emission factor, but they will be kind of globally relevant. And then a tier 2 is more country specific. It might be kind of soil type specific or something like that. And then once you get to tier 3, that's when you're using models, etc. within your approach. And there are, the idea is that the greenhouse gas inventory needs to be transparent and consistent, complete, etc. So there's quite strict rules around it. As I said previously, it's people review it. There are expert reviews every year as well. The transparency is really key. And each annual submission involves a recalculation, as I said, with these reviews as well, either centralised or kind of in country. So within the LULUCF, the land use change and forestry section, the UK LULUCF section the emissions have been coming down since 1990, as you can see here, and it is pretty much kind of on or a bit below zero. It is one of the section really that can be a sink within the greenhouse gas inventory. And then this, but not all parts of the LULUCF are sinks. So as you can see here, forestry is a sink, but cropland isn't, wetlands aren't, settlements aren't, etc. So even though overall it can be, there are elements of it where if there's a bit more kind of work towards lowering those emissions, could see it become more of a source, more of a sink, sorry. And then these emissions are disaggregated as well. Local authorities like to know what their part of the world is doing, national parks, etc. And just to demonstrate, when the IPCC wetland supplement was published in 2014, so this included guidance for wetlands, terrestrial and coastal wetlands. Peatlands were included in 2019, so they were in the UK inventory, and they were the first, only habitat at the moment that has been included from the wetland supplement. And just to demonstrate that it can make a difference, I mean, there's a lot of peatland in the UK really, so it's increased the organic soil reported within the inventory by quite a lot. And then just to show, the red line was prior to the peatlands being included, and then the black line was afterwards. So it did actually increase the emissions from LULUCF, although that is tracking down. Peatland inventory is all about reducing emissions at this time. So salt marshes can be included. They are included in the guidance. And there is a tier 1 default emission factor that can be used. But there has, internationally, there is limited reporting, basically due to data gaps. So at the moment, Australia, the US and Malta all report salt marsh in their greenhouse gas inventories. And then here in the UK, we've been gathering the evidence to be able to do so. So within the guidance, there are default emission factors, and that is shown in the plot here, the red line being the tier 1 mean, and all the different studies that are included in that. And this is associated with re-establishment of saltmarsh vegetation. So the picture here is of a managed realignment site in Essex, UK. So that is the main way of restoring saltmarsh in the UK, and the main way of re-establishing saltmarsh vegetation by reconnecting areas to the tide. So as Martyn mentioned, in 2024, this roadmap was published. Myself and Hannah led this study alongside others, and this has been kind of adopted into the UK Blue Carbon Evidence Partnership with the working group around greenhouse gases, and within that working group and at CH, we've been looking at different parts of this roadmap. But this was really useful to kind of plan out. Within the report, there's more detail, but it was really useful to plan out what needs to happen and a kind of what needs to happen first as well. Not all of it is completely linear, things can happen in tandem as well. But at the moment, we've been focusing on the bits circled here, so reviewing guidance, producing activity data and driving emission factors, and then just a bit of kind of looking at uncertainty around the emission factors. So I'm just going to go through some of those bits of work that we've been doing. So to produce activity data, one of the, you need to be able to know where the habitat is, and also to be able to track change over time, or to check that there hasn't been any change. So there's a paper led by Hannah that came out last year, where we looked at an Earth observation approach for looking at change in restoration sites. And it showed that it was quite accurate, and over 90% accurate for vegetation versus bare soil. Not quite so accurate for different vegetation communities, but we've been taking that forward and we'll be developing this idea. And we also have an ongoing project at the moment to produce the base maps for saltmarsh extent, land use and condition. That's a really important thing for the greenhouse gas inventory. You need to know exactly what you've got and be able to kind of date stamp that. So you can either work backwards or forwards, backwards to your 1990 or forwards to whatever year you are working on at the time. So that is an ongoing work at the moment. There's also been a lot of work developing emission factors, seeing if we could develop tier 2 emission factors, so more UK specific. So the first thing we did was gather all of the data. So we did a big systematic review of over 9,000 papers looking at saltmarsh habitat in the UK, and also temperate northern European climate zones, so places that are very like the UK. And we compiled all of the kind of direct measurements from that, so like greenhouse gases, carbon stock, accumulation, accretion rates, etc., and all of the metadata with that. And with the emission factor development, there's various stages to go through. So visualizing the data, looking at the distribution and the uncertainty of it, fitting models, controlling for study sites, etc. So one study site doesn't have too much of an impact on everything, and then a sensitivity analysis looking at outliers, etc. So the database is published. There's a report about it. There is a data set in the Environmental Information Data Centre, and then there is also this database that's been created. So this is live. You can go on this database, you can plot up data, you can look at the data on a map, you can plot it by reference or country or year, etc. To visualize it, you can also download the data as well. And we feel this would just be part of the transparency part of greenhouse gas inventories. It's really helpful for that. But it also, we feel it will be a really good tool for the research community to use as well. And then going on to emission factors, we have, through that process of the literature review, we have developed a tier 2 carbon accumulation emission factor for both natural or historic, depending on which term you prefer, and restored salt marsh. So you can see here in the plot what the default tier 1 emission factor is, and then where our data sits. So the natural or restored emission factor came out as minus 1.83 when the default emission factor is minus 0.9. There were higher values for restored salt marsh compared to the historic salt marsh, but there's less confidence in that separate value, mostly due to uncertainties, but also knowing how long you would apply that different emission factor to a site before you then went back to using the kind of more the natural one, and we need to do a bit more work on that. We weren't able to develop one for CO2 flux, so there wasn't enough data to derive an emission factor. And we, as part of this and in the report, there are recommendations around improving data availability, which goes back to some of the things Martyn said about making data as useful as possible. Some studies couldn't be included in this analysis because there wasn't clear documentation or clear descriptions of methodology. There were some papers where we weren't even sure whether it was actually measured or it was a modelled value. And also not as, again, something Martyn said, it's really important to put uncertainties around data as well. And sometimes we couldn't use values because there wasn't any uncertainty around it. We also developed a emission factor for methane. There was enough data to do this, but we combined natural or historic marsh with restored. There wasn't enough data to develop that separately. And there is quite high confidence, the uncertainty of this is quite high, but one thing to note was the 95% confidence interval didn't overlap 0, so it does suggest that there is an emission there, but the results were very varied. We couldn't develop an N2O flux. There were only a few studies about N2O. But just to kind of wrap that up, there was we were able to calculate tier 2, so that would be improved representation for UK conditions within the UK greenhouse gas inventory rather than using tier 1. It represented a sink of minus 6.53 tonnes CO2 equivalents per hectare per year, quite high confidence intervals, and this would be an overall sink if we take a 50,000 hectares within the UK of 329 per year, and the report is available for this. We have some future work. We completing the base map. We need to add new papers and data to the emission factor calculations, and then also just to say, and I have 2 more slides, is on the emission factor development could in the future include information from and data from the flux tower network. So UKCEP have set up a salt marsh flux tower network in the UK. So we have 6 sites at the moment, hopefully soon to be 7. The 7th one would be the one in the Solway in Scotland here. The orange dots are where we've got matched pairs with a historic marsh and a restored site in the same location. And we've tried to cover north, east, south of England, lots of different reasons for that, but maybe explanatory variables of why the flux might be different in those different sites, so we can cover those. And we've produced these infographics of the flux tower data. I'm always asked what the data is and when it will be out and everything, but I'm sure people on the call can appreciate we want the time to be able to publish it. So alongside colleagues in EA, these have been developed, so it gives a flavour of the data. And they do show that salt marshes in the UK are net sinks of CO2, but there's lots to explore around that and inter-annual variability as well. And just to say everything I've spoken about, we have a website with all the links to all the different reports, everything we've done over the last kind of 5 years or so on this topic, and that's at that link, and I will put it in the chat as well. Thank you very much.